You know that feeling, right? When spring finally hits. The sun is out, the snow is finally gone, and there's just this weird, restless energy in the air. We call it spring fever. But what is it, actually? Well, today we're going to get into the science behind this whole seasonal shift.
So many of us feel it. You get this sudden urge to just be outside, your mood is all over the place, and maybe you're even having trouble sleeping. And then you look out the window, and it seems like the entire animal kingdom is going a little nuts too. So what's going on here? What's the connection between our own restlessness and theirs?
It turns out this isn't just some nice idea. It's a real biological mystery, and it's got two really fascinating sides to it. What's happening inside our own heads, and what's driving that explosion of activity in the animal world.
And this right here lays out the two main pieces of the puzzle perfectly. For us humans, spring can mean some serious emotional highs and lows. For animals, well, it's the start of the most important time of the year, mating season. So the big question is, are these two things actually related? Let's find out.
Okay, first up, let's talk about us. What is actually happening inside our brains that makes spring feel so incredibly different from that long, dark winter we just survived?
It all kicks off with a pretty simple chain reaction. See, as the days get longer, that extra sunlight is a direct signal to our brain to start making some major adjustments. And it's this big shift in our brain chemistry that triggers all those changes in how we feel and, how we sleep.
Now, here's where it gets really interesting. Look at the specific chemicals involved. Sunlight boosts serotonin and dopamine. Those are our feel-good and get-up-and-go chemicals. That's what makes us feel more energetic and excited. But at the exact same time, it's telling our brain to produce less melatonin, which is the hormone that, controls our sleep.
This whole system is run by what scientists call our circadian rhythm. You can just think of it as your body's internal master clock. And for months, it's been ticking along on a winter schedule. So when all this extra daylight suddenly shows up, it can throw the whole thing completely out of whack.
And the best way to think about it is like a kind of biological jet lag. Seriously, your internal clock is scrambling to catch up to the new, earlier sunrise. And this mismatch is exactly why some of us get insomnia, feel more anxious, or have those really intense mood swings come springtime.
All right, so that's us. Now let's switch gears and look at the second piece of the puzzle. While our internal clocks are getting a little, scrambled, the animal kingdom is responding to that exact same signal in a much more, let's say, programmed way. You see, for tons of species out there, mating in the spring isn't just some random impulse. Oh no, it is a brilliant, deeply ingrained evolutionary strategy. It's basically nature's survival plan, perfected over millions of years.
And would you look at that? It's a very similar chain reaction to ours. More daylight hits the brain, but instead of just tweaking mood chemicals, it kicks the whole reproductive system into high gear. It starts pumping out hormones like testosterone and estrogen, and that's the trigger for all the mating behavior we see.
And why spring? It just makes perfect sense, right? It gives the next generation the absolute best shot at survival. If you're born when food is everywhere and the weather is mild, well, your chances are a whole lot better. It's nature's perfect timing.
Okay, so let's pause. We've seen two very different results here, mood swings in humans and full-on mating rituals in animals. But what's the one thing that connects them? What is the master switch that flips for both of us?
It is time to reveal the one single, powerful force that connects everything we've been talking about, from our own restless nights to all those birds chirping like crazy outside the window.
The answer is a single, powerful force. It's something that basically dictates the rhythm of life for almost every single creature on this planet, from the smallest plant all the way up to us.
It's sunlight. Simple as that. The increasing length of the day and the intensity of the sun's rays, that is the common trigger. It's the universal signal that tells bodies, both human and animal, that a massive change is coming. So let's bring this all home. How do these ancient natural forces, all sparked by the sun, still manage to shape our modern lives today? This table just lays it all out so clearly. The trigger, it's the exact same for both, increasing daylight. But the mechanism and the result are different. In us, it messes with the brain chemicals that control our mood. In animals, it stimulates the hormones that drive reproduction. Now, let's be really clear about something. Humans do not have a biological mating season like animals do. Our behavior is way more complex than that. But that doesn't mean we're immune to the seasons, not at all. We absolutely feel that ancient biological pull.
And this is what our version of spring fever actually looks like.
That same light-driven chemical shift gives us a more active mood, that classic spring in your step. And it gives us a much stronger desire to get outside and actually be around other people after a long winter stuck indoors.
So in the end, it's all one big story. The light of spring literally changes our internal chemistry, and in doing so, it plugs us and every other creature right back into the ancient rhythm of the seasons. It's a pretty powerful reminder that we are still deeply, deeply connected to the natural world.
Which leaves us with a final question to chew on. In our modern world, with all our electric lights and 24/7 schedules, how much are our lives still being guided by these ancient rhythms of nature? Are we losing that connection, or is that pull just too deep in our biology to ever really ignore? It's something to think about the next time you feel that unmistakable buzz of spring in the air. Thanks for watching.